Again, so you're tuned in for another example, I hope, of solving first order differential equation. So here's the first order differential equation we're going to solve. So find the general solution of the differential equation and this. Now the first thing to note is that it needs to be of this form here. It needs to be dy dx plus py equals q, where p and q are functions of x. At the moment we've got a multiple of dy dx, so you just got to divide by that. So dy dx times cos x, the rest of it, you've got to just divide that by cos x, okay? So when you do that, you end up with dy dx here. That will be tan x, because sin x over cos x is tan x, the tan xy equals, and then this here will be 2 cos squared x minus, and then written as sec x, okay? So that's our result. Then what we're after is an integrating factor. Remember, that is the critical part to solving this differential equation. The integrating factor, IF, is e to the integral of p dx. So p is basically what you're multiplying y by. So you're multiplying y by tan x. So the integrating factor will be e to the integral of tan x dx, which is sec x. You can look that up if you want, but I'm just stating that as a known result. The integral of tan x equals the natural log of sec x. We'll just squeeze that line in for you. So the natural log of sec x, and when you have the e to the natural log combined, they just cancel, you left with sec x. Okay. Next step, you multiply both sides of the differential equation here by the integrating factor, and then you solve. So if you multiply this side and this side by sec x, you're going to get this line here. So sec x times that, sec x multiplied by that, so sec x tan x y, and then the right hand side, here we go. So I've not simplified it, I've just written it as 2 sec x cos squared x sin x minus sec squared x. So this bit here can simplify, of course, because you've got cos squared x divided by cos x, which is just cos x sin x. Okay. Now, this is the important result in terms of when you've multiplied by the integrating factor. You can just go straight to the integrating factor multiplied by y equals the integral of, well, basically the right hand side here, which is what I've written. Okay? So the integrating factor, sec x multiplied by y, is equal to the integral of the right hand side. And I've just tidied it up a little bit. Like I said, sec x times cos squared x is going to be cos x. So the integral of 2 sin x cos x minus sec squared x dx. Okay? I'm just going to go on a brief tangent just to show you exactly why that is. Okay? So if I write down this result, d dx of the integrating factor, sec x multiplied by y. If we work out what that is, remember the product rule of differentiation, v du dx plus u dv dx. So if I have that as u and that is v, so the v du dx will be y multiplied by the derivative of sec x. Derivative of sec x is sec x tan x. So y times sec x tan x, so that result there. And then u dv dx, so sec x multiplied by the derivative of y. Remember, I have to do that implicitly when you're differentiating y with respect to x. So sec x dy dx, so that bit there. So what I'm showing you, demonstrating, is that the derivative of the integrating factor times by y gives you that result there. And when you have the derivative of this equals something, whatever it is on the right hand side, you can just use integration to undo that. So the reverse process of the derivative here is the integral, so you're just left with sec x y on the left there, and the integral of the right, which is there. I'm hoping that little bit makes sense for you. You don't need to include that step in your working. I'm just demonstrating for you why this whole process actually works. So we've got that line there. So I'm just going to write that on the next line here. And I'm just going to integrate that. Now, when you've got a trigonometric term, often you can look for an identity to see if it simplifies a little bit. And it does. That is the identity of sine 2x. Okay? So sine 2x, the identity, gives you 2 sine x cos x. So that's just helping me a little bit to integrate that more easily. I can just do that quite quickly in one step without too much thought. And sec squared x is a known integral result. Okay? So integral of sine 2x, so that's going to be negative a half cos 2x. Okay? And remember this integral result? It's just tan x. The integral of tan x, so the derivative of tan x is sec squared x. So the other way around, the integral of sec squared x is tan x. And then plus c. So that is what sec x y is equal to. Often you're asked to write it in the form y equals. So multiply both sides by cosine x to get what y is. So here that will be negative half cos x cos 2x. So this is a different angle. I forget cos 2x. So you can't simplify that nicely. So I'm just left it as cos x cos 2x. and then multiply that, you're going to get just sin x, of course, tan x times cos x is sin x, and then plus c cosine x. Okay? And that's your general solution to that first order differential equation. Thank you for watching. I hope you found that helpful. I'll see you again. Bye bye.